Hello friends, welcome to our channel. Today we are going to see the number of images formed by a pair of plane mirrors when the object is placed between them. We are going to discuss about it. Now let me draw two parallel mirrors. This is the reflecting surface of first mirror. This is our mirror 1. This is our mirror 2. This is the reflecting surface of mirror 2. Now let us put an object between these two mirrors. This is our object. Now let us assume two rays are coming out of this object and getting reflected in the mirror. Again, it can get reflected. Okay, and again it can get reflected. So the process continues. It can get reflected infinite number of times. So let me show the direction of the light ray. So this is how light rays are getting reflected. For each reflection, some amount of light energy is being absorbed. So the energy of the reflected ray is slightly less than the incident ray. So in each reflection, observing a loss of energy. That is why we can see only few images. Now, if we draw a line through O and drag these rays backwards, this can give us images. Now, let us call it image 1. and image 1 will create another image. So image of this image will be created on this side. So this is the image of I1. We can call it I1 dash. Okay, so we have considered only the first reflection. So when we drag these rays backwards, they meet at a certain point inside the mirror. So we are getting our first virtual image, and this virtual image can create another image of it inside the other mirror. Okay, so this is I1 dash is the image of I1, and I1 is the image of O. Now if we drag this rays backwards, that means we are now talking about second reflection. So this is our second reflection. Now we are dragging this rays backwards. Okay, so we are getting another image. Let me name it I2, and because of this I2, another image of I2 will be created inside the first mirror. So this is I2 dashed. Similarly, in the case of third reflection, if we drag it backwards, we are getting another image which is I3. So when I3 is created, an image of I3 will also be created on the other side. So let me call it I3 dashed. This is how the process will continue, and in each step light rays will lose their energy. So the process of reflection goes on. So this is how the process of reflection goes on. Many images are formed. Okay, this is how many images are formed, but the brightness of the images keeps on decreasing. Because at each reflection, some light energy is uh, being absorbed. This is why we can see only few images. We do not see infinite number of images. So this type of image formation can be seen in the barber shop. So we can say in showroom and in a barber shop, this type of image formation is seen. Now if we talk about the mathematical representation of this phenomenon, then we can write mirror 1 and mirror 2 are parallel. That is, uh, the angle of the angle between them is 0 degree. So if we find, okay, we have discussed about the number of images formed by two inclined mirrors when the angle between two mirrors is theta. Okay, so in this case 360 degree by theta. Theta means in this case the angle between two mirrors is 0 degree. So 360 degree by 0 degree, it gives us infinity. That means we get infinite number of images. Therefore we can say infinite number of images are formed. Similarly, we shall see in refraction a thick plane mirror also forms multiple images. Now we are going to talk about The number of images formed by two plane mirrors where the angle between the mirrors is 90 degree. So let us assume this is our two these are our two mirrors, M1 M2. This is the point of intersection between them, and this is the object. Now we know that if we join these 2 points, we are getting a line segment, and using this line segment as radius, if we draw a circle something like this, the object and the images will lie on the circumference of it. Now let me explain it. This angle is 90 degree. Okay, now let me take two rays. Okay, one, two. Two rays are coming out of the object and they are incident on mirror 1. So now they will get reflected. So after getting reflected, they will fall on mirror 2. They will again get reflected. Now we have taken mirror 1 as the first reflector and mirror 2 as our second reflector. If we take the opposite case, that means this is our object. Now if we take the opposite case, if we take M2 as our first reflector and M1 as our second reflector, then actually these two things are happening simultaneously. I am drawing it with two different diagrams to make you understand. But actually these two things are happening simultaneously because light rays coming out of O can get reflected by mirror 1 and mirror 2 simultaneously, right? These two phenomena are happening simultaneously. I have drawn two separate diagrams only to make you understand. So now if we drag this reflected ray backwards, it will meet at a certain point on the circumference. Okay, so this is our first point. Let me call it image 1. And if we take these rays backwards, they will meet at a certain point. Okay, let me call it image 2. So by mirror 1, the direct image of point O is I1, and by mirror 2, the direct image of point O is I2. Now this will, okay, so I1 and I2 are formed. Now I1 will act as a virtual object for mirror 2. Okay, this will act as a virtual object. So image of this image will again be formed. Okay, now I1 is acting as a virtual object for mirror 2. So light rays are coming from I1 getting reflected by mirror 2. So if we drag these rays backwards, they will meet at a certain point on the circumference. Okay, so image of I1 will be formed. Let me call it I3. Similarly, in this case, I2 will act as a virtual object for mirror 1. Okay, so this will act as a virtual object. So image of I2 will again be formed. So this is our object now. So light rays are coming from this object. Okay, light rays are coming out of this object and getting reflected by mirror 1. Okay, so if we drag them, They will meet at a certain point on the circumference. Okay, I am drawing freehand, that is why the diagram is not that perfect, but you can understand it. Okay, so this is our object now, virtual object. The light rays coming out of it are getting reflected by mirror 1, and when we drag this, they come backwards and meet at a point which is I4, image 4. Now, these two phenomena are happening simultaneously. That is why I4 and I3, that is why I1 and I3 are overlapped. Okay, so the direct image of O by mirror 1 is I1, the direct image of O by mirror 2 is I2. Okay, now when this acts as a virtual object, the image of I1 is formed, which is I3, and when I2 act as a virtual object, image I4 is formed, and image I3 and I4 get overlapped. Okay, that is why the complete figure looks like this. Okay, so this is our image 1, this is our image 2, this is our image 3 comma image 4. Okay, these two images get overlapped. That is why actually we should get four images, but we can see only three images because two images get overlapped. Okay, and they all lie on the circumference of the same circle. Okay, so I hope you have understood it. Now if we see the mathematical aspect of it, in this case the angle between two mirrors is 90 degree, therefore 360 degree by 90 degree is equal to 4, which is actually even. So when this ratio is even, we know the number of images formed will be one less than this, that is 3. So when we keep two plane mirrors perpendicular to each other and place an object in front of them, we can see three images. So I hope you have understood it. Now let me come to the next point. In optician's room, to increase the effective length of the room, generally in an optician's chamber, a mirror is placed in the front wall and opposite to that wall a chair is kept facing the mirror. When a patient comes, he or she can sit on that chair and look at the mirror, and just behind the patient's chair, alphabets of different sizes are kept, and when the patient looks at that through the mirror, then the effective length of that room becomes twice, because the letters are kept just behind the patient. Okay, and patient sits opposite to the mirror. So the object distance from the mirror becomes image distance from the mirror. So the effective length of the room becomes twice. We can use plane mirrors as looking glass. Number 3, we can use them in periscope. We can use them in kaleidoscope. Mirrors are Plain mirrors can be used in solar heating devices like solar cookers, solar heaters. Mirrors can be used for security and safety reasons, etc. Thank you.